Today we're going to be looking at element forces in CROD elements that you have after a Nastran analysis. So here is the truss we'll be working with today. So you can see there are a few elements here. Here's an example of what to expect in this tutorial. Now, before going on, quick comments. Number one, the Postprocessor web app is free to any MSC Nastran user. If you want access to the Postprocessor web app, you can go to the site theengineeringlab.com. In the top right hand corner, there's a blue button. Click that button, fill out the form, and then we'll work with giving you your free copy of the Postprocessor web app. The other thing about this tool, it's only compatible. The Postprocessor web app is only compatible with MSC Nastran. It's not compatible with any other version of Nastran out there. Now, to start off with, let's go to the home page of the web app and let's click on Tutorials and User's Guide and go to Postprocessor Tutorials and scroll down until you find this tutorial. CROD, Axial Forces and Stresses. Click on this link and then in the downloads directory, extract this zip file. Inside of this new folder is the bulk data file for this truss and the H5 file that contains the results of the Nastran analysis. Now, this example came from the Patran post-processing manual. I believe this was, let's confirm, this is problem 8, linear statics pin truss analysis. So if you want to get information of the materials, the boundary conditions, and the loads, I recommend that you go through this document to get in more information about those details. Now, if you go back to the web app, let's go ahead and go back to the home page, and let's go ahead and click on the viewer web app here on the far right. And let's go ahead and upload both of those files, the bulk data file that contains our Nastran model, and let's go ahead and upload the H5 file also. So let's go ahead and do that. And before we go ahead and take a look at the results, let's go ahead and look at the model real quick. So here, let's turn on the cross section of the CROD element. So this is what the cross section looks like. One thing you can do here, you can go into first person mode. And here you can navigate and inspect the model like a video game. So here I'm looking at this node or this grid for this corner, and then you can just navigate through the model to your liking. If you want to move into a cross section, you can do that here. So let's go ahead and see if we can do that. And I don't know if it's visible here. It might be a little hard actually. The lines, I was looking for the lines, but maybe that's a little difficult here. Let me go and turn off the cross section and let me zoom out. Sometimes the color of the lines might be hard to differentiate with the white background, so you can click on background color to toggle the color of the background, and now it's easier to differentiate the lines for the CROD elements. Now, let's go ahead and maybe go into Fem label real quick. Let's enter pick mode. Let's go ahead and click some of these elements. Let's go ahead and see what the element IDs are for these elements. We can mark a few checkboxes here to get more information. What are the grid IDs that are being connected? Let's go ahead and reset the labels maybe. What are the degrees of freedom? Normally, that's something you don't see. Here, these are what the degrees of freedom look like for the nodes. And now let's go ahead and jump out of here. Now let's start post-processing. Let's go ahead and go to the front view. Let's go maybe to let's toggle the background color. So here, it's hard to distinguish the deformations, and that's because your scale factor is currently at 10. What you can do, you can increase the scale factor. I mean, let's just do it more and more. And this, when we scale the deflections more, we get a better idea of what the actual deformed shape, not the actual, but we get a better idea of what the deformed shape looks like. And here you can see what it looks like on the screen. Now, what about the values of the deformations? What does that look like? Here in this row of buttons, click on marker plot. And then let's go ahead and click on maybe just the X component of deformation. And then here, maybe we'll turn on the maximum label and maybe the minimum label. So here, if we just look at the X component of deflections, this is what the deformed shape looks like. These are what the values look like. Now, we only report the values at the nodes. So those values are going to be represented by these markers or these boxes or these squares. Now here, let's look at the Y. So here you can see that the values at the nodes, they've changed. What about the Z? What does that look like? This model is not being loaded in the Z direction, so that's why the values are 0. So here, let's just go ahead and select both the X and Y components. And here we get the deformed shape that we saw a few moments ago. Now, let's go ahead and now look at element forces. So we'll select a different data set, element force rod. We'll select subcase 1. And here, let's turn on the arrow plot. And let's turn off the deformation. So click on this button called display shape plot to hide the deformation. And now if we look closely, we get various arrows that represent the axial force in these elements. Here we can turn on the torque, but this model doesn't have any torque on the members, so they're all 0 as you see here on the screen. Let's go back to axial force. And let's look at this, or rather, let's go ahead and turn on a maximum label. So here, the maximum axial force is happening in element 5. And if we zoom in, you see that element 5 happens to be this diagonal member. So we zoom out. This diagonal member happens to have the highest axial force in this model. Let's see, is there anything else worth covering? So we went over the displacements, we went over the axial forces. Let's go ahead and look at maybe the axial stresses. And here, I think what we can do here, let's see, rod forces P1. Let's go ahead and turn on some more labels here. And what I want to do here, if you look at this value in the top left-hand corner, this element has a axial force that is about -514. That's in compression. And if we look back at the Patran post-processing manual, we actually get 500 or -514 for that member. And then if we look at the bottom right-hand corner, this vertical member, if you will, has an axial force of about +363, so it's in tension. And when we look back here at the manual, we get a positive axial force of 363.64, which is aligning to what we have here in this diagram. Now, let's quickly look at the axial stresses. When you look at the axial stresses or strains, it's going to be pretty similar. Here, we're using arrows and these marker points to identify the direction, or rather, if we have compression and tension. If the arrows are pointing towards each other, then the value is compression. If the values are going away from each other, then you have tension. So here, we're looking at the axial stresses. Let's go ahead and turn on some of the maximum labels. So let's go ahead and look back at the table. Here, one of the highest values that we get is about 1,272. And that happens to be in this diagonal member. And then here for this vertical member, we get an axial stress of about 363, which I believe is matching this value too. So here we get a value of +363. You notice both values are positive, so both values are in tension. So if we go back here, this diagonal member, the arrows are pointing away from each other, so we have tension. For this vertical member, the arrows are pointing away from each other, so we have, again, stress and tension. So that's how you look at results for CROD elements. Again, this example came from the Patran post-processing manual. Again, the post-processing manual or the post-processor web app is free to MSC Nastran users, and it's only compatible with MSC Nastran. If you go to theengineeringlab.com and click on the button on the top right hand corner, fill out the form, and we'll work on getting you set up with the post-processing or post-processor web app. We'll either provide you online access or we'll hand you your own installer so you can install it on your own operating system. So with that, I'll stop here and thank you so much for watching.